Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. Before I start the class, so I hope you have already know about the situation about our calendar academic. Okay, so where there is no extension, meaning that the calendar academic will remain the same. So the lecturer need to replace the class. Okay, the 1 week class, but I think we don't have sufficient time to do that. And I think our syllabus is on track, so that's why I think no need to have the replacement class. Okay. Okay, and about your second test, as I mentioned, I think in our WhatsApp group, your second test will be on 19th of January. Okay, 19th of January. I think the time is not fixed yet. Okay, so but by today we will me and also the coordinator, we are the lecturer, Dr. Nik Rumzi. We discuss about the draft, the second test draft questions, which is I think not very tough, not very tough. Okay, so I think most of you, if you do the exercise, I think don't have or no need to worry about the second test questions. Okay, so let's try to do this. This one is 10.67, which is come from your textbook, and I can see that some of you or majority of you have already the solution. Okay, I think yeah, you maybe you can download it from the internet and so on. Okay, because myself, I don't have that solution. Okay, I don't have that the book for the solution for all the questions. Okay, because some of the because I can see that in previous exercise or previous semesters, I can see some of the solution are incorrect, whether meaning that in terms of it answers and the way that they do the solution. Okay, so that's why I don't have that. Okay, so let's try to do this, and I think most of you also have done this one by yourself, but I think we can discuss this class inside this class. Okay, so actually this circuit, as you can see, it looks like a very complicated circuit, or it may seems a little weird because you don't have any experience on dealing with this circuit. But don't be fooled, because this circuit is actually, if you redraw the circuit carefully, you can have the circuit is actually a very simple circuit. Okay, so let's draw this circuit. So actually, the first one is actually about the Thevenin and Norton, and I hope you have already know about when you are asked to find the Thevenin and Norton equivalent circuit, the parameters that you need to find, I hope you have already know, which is you need to calculate the VTH and also RTH. The same case with the Norton circuit, which is you need to calculate the Norton current and also the R Norton, which is this one is actually you obtain, which is open circuit. Okay. Okay, so let's try to do the Thevenin circuit first, and then, but first we need to redraw this circuit. So this circuit is actually composed of a very simple circuit actually. Okay, so I redraw again this circuit. Okay, so this is terminal A, and this is terminal B. Okay, so right now, can you see how can you solve this? So this terminal AB is the terminal output, which is, this is actually the terminal that you need to find what is the voltage. So your VTH is equals to VAB. Okay, which is V open circuit. Okay, VOC, I hope you already know, VOC is actually V terminal across the open circuit. Okay, so right now we have defined it as a AB. So calculate the VTH or VAB. So actually, if you see carefully, this one, because this branch, okay, the first and the second branch is actually parallel with voltage source. So meaning that the voltage across this first and second branch is actually the same, which is 90 volt with a 30 degrees. Okay, the same also this one. So the voltage across this one is 90 volt. Sorry, 90. Okay. So you can either use a KVL here by using this loop, or you can also use this loop. Either one. Okay. So for my case, I think I will do by using this. Okay. So, but first what you need to do is to get the voltage drop across 10 ohm. I think this one is very 10 ohm. This one and also this one. Okay. What is the voltage across 10 ohm and what is the voltage across 8 plus j ohm. Okay. So since this branch is in series actually, okay, this terminal A, why I can ignore this, because this is just a node, okay, not A, and there is no current since this is open circuit. So meaning that these three elements are in series. Okay, so the voltage across 10 ohm, I use a voltage division technique. Okay, so 10 ohm over 13 negative J5. Okay, 13 plus minus, sorry, 13 minus J5 plus 10. Okay, multiply with 90 degrees. Okay, so you can use your calculator. Make sure that you select mode complex. So 10 over, okay, so usually I will use this column. 13 plus 10, I think you can just add up. So this one will be 33 minus 5 shift I. Okay, so just equivalence. So and then multiply with the voltage source, which is 90 angle 30 degrees. Okay, so usually I will convert into a polar form. So I will have my answer is 38.24 with an angle of shift. I think shift equals. So if we give you the angle 42.3 degrees volt. So this is the voltage 10 ohm. Okay. And then next is to obtain the voltage across 8 plus J6. So the voltage across 8 plus J6 ohm. Okay. So this one is 12. Okay. This one is 12 ohm. So same, I will use the voltage division technique. Okay. So 8 plus J6 over 8 plus J6 plus 12. Okay. Multiply with the voltage source, the voltage across these three elements. Okay. So using your calculator, so I will have 8 plus 6i over this one just add up. So this one is 20 plus 6i, okay, equivalent to, and then multiply the answer with the voltage shift angle 30. So convert into the polar form. So 7 to 7, is it correct? It's quite big. 7 to 7, 31. So let double check first. I think 8 plus 6i, okay, over bracket. So this one will be 20 plus 6i, okay, and then multiply with 90 angle 30. Okay. So 43. So need to double check. So 43.50. So 43 volt with an angle of 50.17. Okay. So right now I have already obtained my this one. Okay. So assuming that all the current is entering the positive terminal here. Okay, sorry. So this one positive, negative, meaning that this one positive, negative, this one is also positive, negative, this one positive, negative, and this one also positive, negative. So the polarity, you need to remain that like that. Okay, so meaning that by using the KVL here, okay, so you will have KVL 1. Okay, so you will meet negative V10, okay, plus VAB plus V 8 plus J6, right? Is equals to 0. So your VAB is equals to V10 minus V8 plus J6. So you can calculate V10, which is already obtained here, 38.24 with an angle of 42.3, okay, equals to, and then minus 43 angle 50.17. So convert into a polar form. 7.3 negative 84. Is it correct? I don't know. Maybe for those who have the solution can share whether the answer is correct or not.
I got the same answer.
Sorry? The same answer.
Yes.
Okay. So, okay. So I hope you know on how to obtain for usually the KVL here. So how the polarity is, right? Because from the what we have learned from the voltage division, so usually we assume that the positive is here and negative here. So meaning that all the positive, negative, positive, negative. Okay, so you should remain like this, and then using the KVL, so the polarity is the same. You need to follow. Okay. Okay. I don't know whether the answer is correct or not. Let's maybe this one is this one is the odd numbers. So usually for the odd number, we have the we have this one, which is 10.67, right? 10.67. Usually we have the answer. Yeah, 7.415 with an angle of negative 84 point. So maybe some point there is a difference, but I think it's not a big problem. Okay, because we do some what I call the round up and so on. So that's why we have some minor error there. Okay, but it's okay. Okay, so any question before we proceed with the RTH? Okay, so let's go for the RTH. So for the RTH, you need to kill the voltage source. Oh, why so big? Why so delayed? Okay, so you need to kill V. So meaning that your V source must be set equal to 0. So when V source is equal to 0, mean that this one is short circuit. Okay, short circuit. And then you need to calculate the RTH that sees from this terminal. Okay, so meaning that you can see that this one, okay, okay. So what can you see from here? RTH. This one is 10 ohm. This one is 3, negative J5. This one is 12. This one is 8 ohm. And this one is J6, positive J6. So what is the R equivalent that sees from this terminal AB? Okay, so you can see this one. I can see that this one is actually similar, right? This not. So actually all are connected same. What can you conclude?
Vx equal to 0 here.
Sorry? Yeah, this one right now, the V, the voltage source is equal to 0. So that's why right now the voltage source is short-circuited. So right now, what we want to do is to find what is the equivalent resistance since from this terminal AB. So calculate your RTH. What's your RTH? Equivalent sorry, not equivalence, resistance. Sorry. Uh, actually, this one is Z. Okay, impedance. Sorry, impedance. Okay, because right now we are in AC. Okay, so sorry, this is not RTH. It should be ZTH, impedance. Okay, sorry for that. ZTH. So what is your ZTH since from, which is ZAB, since from this terminal? So you need to simplify the circuit. Can I say that all these resistors are in parallel? Are you agreed? Okay, so let's try. So this one is 10. Okay, and let's.
Doctor,
This
why
is
doctor?
okay. So let me explain. Okay,
Okay.
let we go step by step. Okay. So this is your 10 ohm. Okay. And then this knot is actually this knot. And it is shared with another branch, which is, I can say that this is 3 and this is -5. Okay. And then it share the same knot, right? With here and here. So that's why this one. Right? Okay. So this one is 3, -J5. Okay. And then this knot is shared with two elements, 12 and 8 plus J6. So I can put this one, 12, and this knot shared with the another element, 8 J6. Okay. And as you can see, these two elements, which is 12 and 8 plus J6, also shared this red knot here, right? So that's why, right? So this is the circuit that after simplification. Okay. Agreed?
Doctor,
Yeah.
for the blue color dot, that side, why
Yeah.
not 8 ohm with G6 ohm?
Sorry, tak berapa jelas lah, not very clear.
For the one blue color dot that just now doctor withdraw,
Yes, okay.
the
Okay.
bigger one now is 12 ohm, right?
Yes.
Why not is 8 plus J6 ohm? Because if we withdraw from the above circuit,
Tak dapat tangkap lah yang the last tu. What 8 plus J6.
oh,
I
doctor,
cannot catch that. Okay.
should be A plus J6 is below the blue dot. Is it?
Aha, okay. Oh yeah. It's actually the same because parallel kan. Tak apa. Tak ada masalah. Okay, just to, it's actually the same because it is in parallel, so no big problem. So just
Okay,
okay.
okay. Thank you,
And then
doctor.
J6 and this one is 12, right? No big problem because parallel. Okay, agreed
Okay,
right now?
thank you, doctor.
Okay. Because actually this one is, yeah, is quite confusing because, but you need to look at the knot here. This knot is actually connected to all branch. Right? The only knot that separate them is actually green and blue. But this red knot is actually all connected to the branch. So meaning that this is the common point for all branches. Okay. So from that, you can see that this one parallel and this one is also parallel. So what you need to do is your sorry, not RTH. Okay, ZTH. Okay, your ZTH is 10 parallel with 3 negative J5, and then after that plus. You need to parallel up first 12 with parallel with 8 plus J6. Okay, because this one is actually if you simplify this, you will obtain like this, A and B. So this is the element for this one, and this one is actually this one. So as you can see, after you simplify, this element and this element are series, right? In series. So that's why it's actually a plus. Okay. So let's try.
Doctor, I
This
think
one.
that it is not 3, it's 13.
Sorry.
Instead of 3, 13, the value.
Instead of. What do you mean?
Value, Doctor, the value of the resistor. It is
The value of
13,
the
not 3.
Is it 13? Oh, thank you very much. Thank you very much. 13. Okay, thank you. Okay, so let's look at this one. So this one 13 negative J5. So can you calculate together? So 13 negative J5 and multiply with 10 and then 13 negative J5 plus 10. Okay, so and then this one is also 12 multiply with 8 plus J6 and then over 12 plus 8 plus J6. So use calculator. So mode, make sure that it is complex mode. So I usually will use this bracket. Okay, 13 minus 5. Okay, bracket and then multiply with 10. So equals to what? The value. And then after that, divide my answer with 13 minus. So I think this one you can just sum up this. So this one is 23 minus 5i. Close the bracket. So this one will give you. So I usually convert into polar. I don't know why. This is my preference. Okay, 5.9 with an angle of negative 8.7, 8.77 ohm plus this one. Okay, the second one. So 12 multiply with bracket 8 plus 6i. Okay, equals to. So and then divide by this one is 20 plus 6i. Convert into a polar. 5.75, 20. 5.75 with an angle of 20. Okay, so this answer, so I think 5.9, you can actually store this one. For example, if you calculate the first element here, you can store and then you can just store in the memory of the calculator, and then you just, for example, you store it as a memory A, and then the second element you store as a memory B. Then you just use your calculator to add the memory A plus memory B. So then you can just get directly the answer. But I don't remember the function is. You can explore. Okay, so 5.9 angle, oh sorry, this one 5.9 with an angle of negative 0.77, okay, plus 5.75 with an angle of 20. So since this is the ZTH impedance, so the answer should be in the rectangular form. So 11.23 plus, I think plus 1.06. So let's look at the answer. Yeah, 11.243, 1.79 ohm. It's slightly different, but I think no problem on that. Okay, because the way that we do is actually correct. Maybe because of the round up of these elements, so that's why we have some slight different on that. Okay. Okay. Any questions before we proceed with the Norton equivalent circuit? Okay, so thank you very much for for the Norton equivalent circuit. You can just directly use the source transformation. Okay, the source transformation, which is you have already obtained the VTH. What is the answer for the VTH? Let's just use the answer here. 7.415 negative 84.68. 7.415 negative 84.68. And your ZTH is obtained, which is 11.2 4. So let's try use the textbook. J 1.079. Okay. So actually your I Norton is actually VTH over ZTH. So it's simply like that. So you can calculate, you should get the answer. Okay. So the answer should be same with this one lah. So which is 7. Okay, let's try 7.415 with an angle of negative 84.68 equals to, and then my answer, and then divide by my ZTH, which is 11.24 plus 1.079 I, and then close the bracket. So my answer should be 0.65 with an angle of negative 90. Okay, so 0.65 with an angle of negative 90 degrees amperes. Okay, and actually your ZTH is equal to your Zn, which is same, which is 11.24 plus J1.79. Okay, that is the simplest way, okay, by using the source transformation relationship. But actually, let me show you on how to obtain. For example, if you don't have the values, you didn't calculate the value of the ZTH and also your VTH. So let's try to obtain first the I Norton without knowing the VTH. Okay, so how to do that? Oops. Okay, so find IN. Okay, so we assume that we don't know the VTH. So to find the IN is actually the short circuit. So what you need to do is you need to short circuit this load terminal. Okay, so this is the I Norton. Okay, so it looks like macam complicated lah. Okay, because this one right now, this knot, okay, this knot and this knot is actually same knot because it is short circuit. Okay, so what you need to do is actually to get the IN. Okay, what you need to do is to obtain the current here. Okay, so this one is your IA and maybe the current also here. So this one is IB. So based on the KCL at 1, okay, so from here you can see that IA is equals to I Norton plus IB. So your I Norton is IA minus IB. Okay. So how to obtain the IA and also IB? So we need to redraw the circuit. Okay. So the circuit we redraw back same like the previous one. So this one I think for simplicity, not Siti Nurhaliza lah. Okay. To simplify the circuit, so I just put the block here. So this one is 13 minus J5. Okay. And then we have this one resistor, 10 ohm. And then we have another one, which is 12 ohm. And then, okay, I have, sekejap ada orang, okay, let me, excuse me first, okay. Okay, sorry for that. So this one is 8 plus J6, okay? So and then you know that this is short circuit. Okay, but don't worry, because what you need to do is actually to obtain the current here. And then I assume that this is my IA and this is my IB and this is my IN. So what you need to do is actually to, since we know that this knot to this knot, the voltage is same, which is 90 degrees, right? Okay, so to get the IA, you get the voltage first. This one is VA. Okay, sorry lah, this one I think not VA. So this one just name VX for example, and then this is your VY. Okay, so what you need to do is to get VX. VX is the voltage by using the voltage division technique. Okay, so 13 minus J5 over 23, you sum up the resistance, negative J5, okay, multiply with the voltage across the element, okay, and IA you obtain by using Vx over 13 minus J5. Okay, so same case for Vy. Okay, so 10 over 23 minus J5 multiply with the voltage, total voltage. And then after that, you can calculate your IB. Your IB is actually 10, oh sorry, VY over 10 ohm. Okay. So after you have calculated IA and IB, so you can use the KCL. KCL here, not 1. So your IN is actually IA minus IB. Okay. Okay. I think that's all from me. Because I have an urgent meeting after this. Just got notification. Okay. So please, maybe you can continue this, calculating it for me, and then maybe you can share the answer whether it is correct or not. I think this is actually the way it is computed. Okay. Okay, thank you very much for all your attention and cooperation throughout this class. Okay, so I think we can dismiss this class. Okay, thank you very much.
Thank you, Doctor.
Okay,
Thank you,
Assalamualaikum.
Doctor.
Thank you, Doctor.
Thank you,
Thank
Doctor.
you, Doctor.